Hello everyone, and today class is about complex notation. Some of you are wondering why we are studying complex notations, and the answer is the complex numbers are going to help us in solving or easing solving the vibrational dynamics problems. So let's have some brief about this complex notation by which we can apply for the next chapters. So if you look at this diagram, which has the complex plane, right? So it will have two coordinates, the real coordinate and the imaginary coordinate here. So the real coordinate will be varying between +1 and -1. However, the imaginary coordinate will be varying between the imaginary number, which is +j, to the minimum value, which is -j. As you see, this is z, which is a complex number, which is moving around this circle, right? Maybe this direction, and this complex number will vary as it's gonna move around the circle. This complex number will have an angle theta between it, the real coordinate, and the point at which z is located in. Also, this complex number will have two combinations, the real combination or the real factor and the imaginary combination as well. And this one can be illustrated as z equal to cosine theta plus j sine theta, whereas j is going to be a complex value of square root of -1, right? So this is what we understand about j. So if we would like to expand, for instance, you expand the cosine, which is the real part of that number, and j sine theta, we can, for example, we can use Taylor's expansion. And this is, you have studied in the mathematics course. So for sine theta, Taylor expansion of sine theta is going to be theta minus theta to power 3 over 3 factorial plus theta to power 5 to 5 factorial minus theta to power 7 over 7 factorial plus, and so on. All right. However, for cosine theta, the Taylor series is going to be 1 minus theta squared over 2 factorial plus theta to power 4 over 4 factorial minus theta to power 6 over 6 factorial plus, whatever. You can notice that for sine function, we have power 2 as odd numbers, right? Whereas cosine, which is an even function, is going to be having even powers like 2, 4, and 6, right? So this is we have to put that one always in our mind, that the sine theta is going to be odd and cosine theta is always to be even function, right? So now we would like to find a solution for the complex number, or another expression of complex number based on sine and cosine Taylor expansion or series. So first thing, we have to understand that j, if we squared j is square root of -1. Therefore, if we square it, j squared, what we'll get? We'll get -1 as well, right? Without any square. So that's very important to understand. However, if we have j to power 3, what you will get? You will get j as square root of -1 multiplied by the what you will have, it will be j multiplied by j squared, and j squares, as we knew that it's -1, then what we'll have, we'll have minus j. So now we can understand what's j in here. And also, if we think about j to power 4, what you will get? It's very obvious. Then what you will get? J to power 2 multiply j to power 2. Then we have -1 multiplied by -1. That will give us +1 as a solution. Right? So we need to understand that all of these terms, j squared, j to power 3, and j to power 4. Then we can implement it in this Taylor expansion. Alright, so let's go first to cosine theta. Cosine theta, if we think about it, if we plug in j, okay, if there is a j squared in here, will be minus, isn't it? For the cosine, therefore, cosine theta, right, which is this one, if we have it as, if we plug in j in cosine theta Taylor's expansion, what you will get? So you will get 1 in here because we don't have anything. But if it is j squared, what you will get? J theta all squared. J squared is going to be what? It's going to be -1, right? So to make this expansion correct, when we plug in j, so this one j squared would be -1. Therefore, minus multiply -1, it's going to be plus, right? Then it's nothing though. J, then don't forget about 2 factorial. But if you, it's similar, this one is similar of this one. There's no change. But remember that this is plus, okay, and this is minus. So, sorry, I need to rewrite it again. All right. So what we'll have again, j theta squared over 2 factorial. Right. So means this one will be plus, same as this one, which is a negative value. Why? Because j squared is -1. So minus theta squared over 2 factorial, similar what we are going to get in here. So now this is totally clear. If we use theta to power 4, what you will get? You will get as minus, oh sorry, j to power 4, then we'll have j to power 4 is going to be positive 1. So if we plug in j theta to power 4, there is no change. J to power 4 will be +1 multiplied by plus, we'll get +1. So over 4 factorial. Then if we are thinking about theta to power 6, that's what's that? So we have to plug in j to power 6. J to power 6 will have, j to power 6 means So j to power 6 is gonna be j to power 3 multiply j to power 3, but j to power 3 is nothing but minus j, right? Multiply minus j, and that's gonna be j. Right? Minus j multiply minus j is gonna be so j or j squared. Okay, j multiply j will be j squared, and j squared will be nothing but it's gonna be minus 1. So, and that one means we have j to theta to power 6 over 6 factorial, and j to power 6 is gonna be minus 1. Therefore, this one minus 1 multiply plus is gonna be minus theta to power 6, and so on. Then we have plus, plus, plus. Everything will be a positive. Similarly, we'll use that for, if we use that for, we plug in j in j sine theta. So we multiply by j sine theta. So we have a j sine theta. It's gonna be j multiplied by what we have in here, theta minus theta to power 3 factorial plus theta to power 5 over 5 factorial minus theta to power 7 over 7 factorial plus, and so on. So if we have multiply that one by j, what are you going to get? You are going to get as j theta minus, or let's make it j theta to power 3 divided by 3 factorial. J to power 3, it's gonna be minus j, and minus j multiplied by this term, you will get it as positive, right? So you'll get it as positive. Similarly, we'll have plus j to power theta to power 5 over 5 factorial. This is positive, right? Because we have j to power 5, and j to power 5 will have j to power 3 multiplied j to power 2, all right? Because j 3 multiplied j2 will be j to power 5 minus 1 multiplied minus j, then we'll get positive j, and it's always positive in here. Then we will have another positive thing, which is j theta to power 7. That, what does it mean? J to power 4 multiply j to power 3. So minus j multiply 3, and that's gonna be, will be minus j. So minus j multiplied minus, which is this value, you got positive j theta over 7 factorial, and so on. So now we have the two combinations, or the two terms, which is the real term and the imaginary term of the complex number z. So if we add them together, what you are going to get? So that means z, which is gonna be cosine theta plus j sine theta, and that will be, you will add 1 plus j theta, then we have here plus j theta squared over 2 factorial. In here we have plus j theta to power 3 over 3 factorial, okay, plus j theta to power 4 over 4 factorial plus j to power theta to power 5 over 5 factorial, and plus, 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 and we continue all the way. This one, if we are good in mathematics, we can know that this is the Taylor expansion of exponent of j theta. Okay, j theta. Therefore, we can determine the complex number z as the exponent number of j theta, right? If we think about a simple harmonic motion, you remember simple harmonic motion. Okay, we have to think how frequent, how fast it's gonna that oscillation works. Okay, so z rotates around the angular velocity, or z is gonna rotate. This z, which is the complex number, is rotating at an angular velocity omega, right? So therefore, the speed of, or the theta, is gonna be, or the speed of rotation of z will be depends on theta, and that will be theta is equal to omega t. So the angle is going to be how the speed multiplied by time, which is the displacement multiplied by time. So and therefore we can make simplify the equation again. Cosine theta plus j sine theta is going to be equal to cosine, we substitute theta as omega t plus j, sine omega t, and that will be in exponent function as j, not theta but omega t. So that's how we develop this formula, or this exponent number. But we always think about the amplitude 8 and also phase shift angle. For the simple harmonic motion, where should we put this one in? Of course, we have to multiply that. We have to multiply by the amplitude, and we have to put that one theta also inside this parenthesis. Okay. Therefore, finally, we will have z cosine, which is omega t. Should be don't forget to multiply it by the amplitude, omega t plus phase angle. Then we add j multiplied by the amplitude, sine omega t plus the phase angle, and that one will be e to power j, amplitude also, j omega t plus phi. So now we are getting more precise value for that. Okay. So this one will be, when we put the initial conditions, this one, when you have initial conditions such as time and amplitude and the phase angle, then we can know the complex number, exact complex number of that. All right. All right, let's stop at here, okay, about the complex notation, and I'm going to tell you about how to apply the complex numbers or notations in our study in the next chapters. Thank you for listening.